Hi everyone, I'm Paweł, and today I'm going to talk about Entity Framework Core Basics. I want to show you a few things which I use at everyday basis in a work, including testing. Keynote here, I'm going to use .NET 7, but it will also apply to pretty much every .NET from .NET Core 3.1 to probably .NET 8 in future. Those things are kind of interchangeable, and maybe some syntax and structure can change, but those are core things related to Entity Framework. So the quick question is what you can find here. Basically, I'm going to quickly explain what is Entity Framework, what are types of it, what are migrations in code first, what is the terminology used across the whole video, and probably the one which you'll see the most with Entity Framework, how tracking objects works and what it is, and how typical Entity Framework application schema looks like, including DbContext, what are relations and how to configure DbContext. And at the end, I'm going to show you two ways of testing. First, unit tests with mocking, and the second one, integration testing with in-memory database. If you would say in one sentence what Entity Framework is, it's an open source object relational mapper for .NET from old versions like .NET Framework to currently available .NET 7, and it will be available at .NET 8 too. Object relational mapper is basically a technique which allows you to query and modify database with object-oriented programming language. So, for example, C#. Instead of writing SQL code, you can write C# code for changing schema, for creating database, but also for getting data and modifying values in the tables. There are two ways to work with Entity Framework. First one is code first, and the second one is database first. Both of them are pretty much the same, but the main difference is that database first operates on already existing database, but code first creates a schema inside an application and then can create a database with it. So the migrations is a big difference. I will talk about them in a moment, but both of the querying data, changing values in database, maybe not changing schema, but changing values from records, it's pretty much the same across code first and database first. Just a big thing, I'm going to talk about code first in that particular tutorial, in that video, because that's how I written the whole application. So in order to have everything clear, I'm going to stick with a code first approach in that video. Two most common used words here is entity and DbContext. Entity is basically a class which is mapped to a table in database. Of course, entity can mean a lot of things. In that particular context, that's what I mean. It can be not directly mapped, can have some different properties, different values, but about configuration I'm going to talk about in a moment. About DbContext, it's basically a bridge between entities and database. It contains information about them, the structure, data types, and configuration. It allows to read and save data in database. It's a most used thing in Entity Framework setup and querying from DB. So how Entity Framework really works, it's a very complex thing, but from a high-level perspective, we've got our application, which has some DbContext, and the DbContext has some properties with, for example, entity A, B, and C, and those are mapped to a tables in database. And when we are going to ask for a particular entity, let's say entity A, with a DbContext, the DbContext will create an SQL query, which will be used to ask a database, then get a result from it, and map it to type which we have added as a property in DbContext. So in our case, entity A. And if we are using complex where statements with link, for example, then that link statement is going to be translated to SQL query and the result will be retrieved. So what is the application I'm going to use in that particular video? It's a .NET 7 web API, which has basically a to-do list functionality, we can say. It has a to-do items controller, which has some CRUD operations like changing status and adding getting, and also removing items. But also The to-do items contains some particular catchments, let's say attachments. Those are the files which you can add in to-do item, and they are kept in storage account in Azure. For that, I'm using Azurite. If you don't know what it is, I've got a first video in the channel, which is named Azure Emulators, and there you can find what Azurite is and how to configure it. It's basically an Azure Storage Account emulator for local development. Application is created with a structure of clean architecture application. I'm going to add to a description some reference if you don't know what it is or how to create application with it. There are two entities. The first one is to-do item. It has a few properties like name, description as in completed, but also has a reference to attachments, which has a path in storage account ID and a reference to to-do item to which it is assigned. That's pretty much the application. It's using very simple communication with services, and services are using DbContext. The whole application will be in description in a GitHub, so you can check it out. If you will have any questions about the structure or why it's something done like that or the other way, I can explain it to you. So where's the DbContext in application and how does it look like? We can find it in infrastructure, persistence, and there is application DbContext. There's key thing, it has to inherit from DbContext class from Entity Framework library, but also it inherits from my own interface in application layer, which you can find there. The idea was to basically don't have application layer referencing the infrastructure layer, so going with clean architecture approach. So I had to add Entity Framework Core reference to application, but with that I'm not referencing application with infrastructure in application. More about that is added in clean architecture approach description, which I've added in description. Yeah, we've got a few things here. First one is the properties added, and those are basically mapped to our tables in database, to the items and to the attachments. Name of those properties are names of tables in database by default. You can change them. Also about the configuration, I'm using option like apply configuration from assembly, and there I'm specifying the assembly of the infrastructure project. I have added configuration in the folder right here, where is, for example, to attachments configuration. I've said it has key and it's not clustered because that's a GUID, and clustering a GUID is basically a bad idea. Also, there is a to-do item and there is specified some things for it. For example, name can have max length of 1000, but it's required when you're adding an item to a database. Same clustered false for GUID ID. We can specify a lot of things here with a builder. A lot of things like indexes, keys, stuff like that. I have also added a relation between to-do item and attachment. If we were not going to specify that one, it's still going to work because Entity Framework understands that this is a basic relation between those two because we have added I collection of attachments here. But I just like to specify it. You have a pretty wider control over it, and you can add some things like fortune key, which you can specify an own value. It can be even a private field in an entity. So it's just for readability purpose. I'm adding them here. But as you can see, a to-do item has many attachments, and those attachments have one to-do item. There are three types of relations. There is has many with one. There is has one with many. So for example, has one to-do items list, and the list has many to-do items in it. And also there is has many with many. For example, many to-do items have many users assigned, and many users assigned have many to-do items assigned. And those can be the same across the users and to-do items. So about migrations, what are those? It's basically a way to update schema of database and keep track of changes which you have done in DB. So I'm going to show you it in an application, how it works, and few features related to it. Let's imagine we have an application which is already done by few developers, and we want to set it up on our machine to just have option to debug it, to have access to database. So first thing which we need to do is go into our web application, app settings.json. There should be somewhere SQL database connection string. We can try to find it by taking a name of it, pasting it right there, and maybe it's used in dependency injection in our place where we are adding our DbContext. We are specifying that we are using SQL server, getting connection string. So basically, as you can see, section from app settings.json named connection string and the name of it. And we are also specifying that migrations assembly, it's assembly of our DbContext, so infrastructure. If we will go there, we have already a migrations folder, so we can check it out. There are two files. First one is our migration. It's created by Entity Framework library, and it contains the differences between last migration state of DbContext and the current state of DbContext. We are going to add migration in a moment. There is two things in migration: what we are adding to database, what are the changes, and how we can revert them. Because migrations allow us to also revert a database, reroll to a previous version. And there is also a snapshot, which basically contains whole structure of DbContext at the present moment. So if there is 1,000 migrations, snapshot is the last version of database using those migrations. In order to add our database to our system, we have to add an SQL server installed on our PC, and I've got also SSMS, so Management Studio. And as you can see, there are no databases yet. I'm going to app settings.json. I've created a connection string, which is specifying my SQL server. So it's localhost MS SQL server 01, double slashes because it's JSON. Name of database will be to-do database. I'm adding trusted connection and trusted server certificate. So I don't have to specify any username or password. What I have to do is go into Package Manager console, specify as a starting project my web application, which contains app settings.json, but also it contains add infrastructure code, so the one which is adding DbContext. And the second thing, I have to specify default project in Package Manager console, which will be the one containing DbContext. So in my case, it's infrastructure. And what I have to do is basically type a command update database, press enter, and here we go, it's done. One important thing, in order to have it working, you have to have library added in your web project, so the one which contains app settings.json for Entity Framework tools and also Entity Framework design. Those two packages are required in order to create the database on your machine. And now when I will refresh the SSMS, there you can see there is my to-do database with 3 tables. 2 of them are basically mapped entities with some particular columns, but there is also one Entity Framework migration history. And if we are going to check it, we can see there is migration ID, and it's basically the same name as the one migration here. It's also product version, the version of Entity Framework Core, which I have used in that tool. Okay, we've got that. So now, if we want to change the schema of database, first we can do it, and then we will add a migration. So let's go into app DbContext and let's imagine maybe that our to-do item has a subtitle. Let's imagine. It's name and it has a subtitle. So I'm going to create a property named subtitle. I'm specifying the default value as string empty. I can specify whether it's required. Maybe let's go there and let's say it's not required. So the name of it is subtitle is required. We can specify false. Okay. And by the way, that syntax, if I have specified string here, should work. Okay. Now I have that changed, but when I will go into my database, nothing changed yet. So in order to have it in database, I have to add a migration. I'm going to, again, have a default project infrastructure, web specified, subtitle added here. I have to type a command add migration, and let's say subtitle for to-do item added. I want also to specify some particular location to have it kind of structurized, don't have all the migrations in one directory. At some time it can be like 100 migrations and it's very hard to navigate through. So for that, let's add /o -o and let's add migrations folder name /2023-04. So the migrations folder, the present year, and the present month. And I also see I have a typo here. So, okay. And let's press enter. Okay, migration is added. And as you can see, the only thing which is changed there is that we are adding a column named subtitle to a table to-do items with a type and var. As you can also see, there is a drop column in a down section that when we will revert the migration, then the subtitle column from to-do items is going to be removed. Okay, we've added the migrations. So is it already there? Let's refresh. Nope. In order to have it there, we have to type our command, which we did already. So update database. That basically means we will apply our migrations from the migrations folder and using a snapshot to our database. Let's take a look again at EF migrations. There is only init. I'm going to press update database. Migrations executed. And now, as you can see, subtitle for to-do item added, migration is right there. I'm going to refresh columns for to-do items, and subtitle is right here and var with a nullable property, so it's not required. And okay, we've got migration added. We've updated our database. Great. But let's imagine we don't want to. Something happened and we want to revert our database. What we can do? For a local environment, what I would do is basically git revert the snapshot and remove the migrations. Delete the migration we added, and then delete the database and type update database again. That's the one option if you are using local database, of course. The other one would be to basically revert a migration. So we can specify update database and specify a name of a migration with which we want to revert, and every other migration after the one which we have specified will be down method applied to a database. So now I'm going to use update database with the init migration. Press enter. Now we have removed it. I can check what is applied. Here you can see there's only init applied. And if I will refresh columns, there is no subtitle right there in a columns in to-do items. Now what I can do is basically remove that migration and git undo changes for that particular snapshot. And now I can work again. I can remove that, subtitle and remove the property from right here. And there are basically no traces of me checking something, doing some changes. Let's imagine more business case scenario that we want to have our database scripted to an SQL script. So we can use it, for example, to deploy on some external machine where we don't access because of VPN connection or something like that. Or we just want to pass to our colleague a SQL database structure. So what we can do is just basically type a command script migration, press enter. And as you can see, the script is created. It contains to-do items, to-do attachments, and it's inserting our migration in Entity Framework migrations history. You can specify also to add it only if the migration is not applied, and it can pretty much behave really close to using update database command. It's a great way to deploy databases to services where you don't have access to. So Entity Framework has something like tracking objects. And what is it? It's basically a situation when you retrieve from some entity from a DbContext and it has tracking enabled, it's a default behavior, then whenever there is property or field change on it, and that property or field is directly mapped to a column in database, then when DbContext has save changes called on it, database will be updated. So when there is no tracking on particular entity retrieved from a DbContext, and you will modify it however you want, for example, you will change 3 properties on it to totally different value, and then call as save changes, nothing will be changed in database. But when tracking was enabled, then those values are going to be changed in database. So it's a very important thing to remember. So in one sentence, Entity Framework is tracking objects retrieved from a DbContext. So when something changes on it, you will know that and can update that value in database on save changes. And there is a very important thing here. If you will pass an entity to, for example, front-end model, and front-end model will change, let's say, a data structure in order to have it common across the whole application, but in database it looks differently, and you will somehow call as save changes on a DbContext which was used to retrieve that value, then you will change it in a database. So you have to be very careful with passing objects to a UI layer. And the very good practice is basically always map an object which is retrieved from a DbContext to a DTO, which is passed later to a UI. Never use entity objects directly from DbContext on the UI layer. Let's check out how it works. So let's go into to-do items controller. I've got a method for updating. It's named change status. I will go there. I'm finding an entity by an ID, and I'm changing is completed status to a negation of it. So if it's true, then it's false. If it's false, then it's true. And I'm calling save changes async on it. Let's, for a moment, comment that save changes async. So we will have not called it. Yeah. In database, we've got a to-do item with that ID. Let's open our application. Go. Okay, let's check the ID which we want to have. That's an ID. Okay, and let's put it right there. Let's put a breakpoint right here, and let's execute a method. Okay, for now is completed is false. For item retrieved from a database, I will click F10. Now it's true. Okay, great. So it's changed. We click F5. We receive a 204. That's a success. Great. Let's check in DB one more time. It still has false. And when I still has 0, and when I will refresh, there is still 0. Now let's change it to call save changes asynchronously. So let's put a break. Let's call it one more time. We go and let's uncomment it. Okay. Then now call save changes. Okay. Then F5. To offer again. Great. Now let's call the endpoint. And it's completed is true. Okay. And in database, the value is 1. So when save changes was not called, then basically the value was not updated in database, even though we changed the value right here. The other case scenario is that when we will retrieve an item as no tracking. Let's do it right now. Let's stop debugging and add as no tracking. And also instead of find, let's use first.default where s.id is equal id passed, and we are passing cancellation token. Okay, first.default asynchronously as no tracking. Item is still the same. We are changing a property and calling save changes. Okay, let's open the application. Here we go. Let's get our item. Is completed is true. Let's copy the ID, go into put and change the status. Let's execute. It's true. Then now it's false and save changes is called. Right now F5 204, so no content, all good. Let's retrieve an item again. Still true. Nothing changed. So even though save changes was called, and the property was changed, item was retrieved as no tracking. So Entity Framework was not taking its resources to know what changed on that particular entity. By default, all the entities retrieved from Entity Framework has tracking enabled. Sometimes you just want to disable it because it will take some memory, some space. And if you are not going to modify the value, you are just going to, for example, retrieve it with an API, with a GET call, it's a good practice to use as no tracking. I have mentioned mapping an entity to a DTO, so let me show that. We've got a to-do items controller, which have a method getCall, getAll. And inside that method, maybe let me expand that. What is happening right there? First thing, we are retrieving all our to-do items from database using include. I haven't mentioned that yet, but basically if we have a relationship in our entity, by default, Entity Framework is not retrieving items of that relation. So without include, we will only get to-do item objects. So all of that, but without that. That will be empty or null. And that will be empty as I specified a new list. Why is that? Basically because of resource management, and in order to don't create a huge SQL queries which are not required. So if we want to have attachments, so our relationship, we have to use include option. If we want to have in attachments a reference to our to-do item, then we have to use something like then include and specify a to-do item right here. And we can go with that includes and then includes forever. Just to remember, every include can create a bigger query, and it will basically. So if you have 12 includes in your SQL query, it's a good moment to think about why. Sometimes you need, sometimes you don't. Using include all the time is a very bad practice, which can slow down your application a lot. So try to use it carefully. Right there, I'm retrieving an includable queryable. So toList is not called on it yet. So request to database is not done yet. The request to database is that only in a moment of calling toList or in a moment of just retrieving it out of our system. So in our case, returning the value from a controller, the moment when the controller finishes, then the SQL is called and then the values are mapped using IEnumerable with yield return. For now, there are not items there. If I'm going to call fullList on that, then that property has items from database and query has already happened. Same case with first or default. Basically, it's creating a solid collection. So right there, I'm using for each on that items with yield return and async enumerable. And I'm returning a new DTO, mapping the properties basically to the same state. ID is completed, name. But I also have attachments in to-do item DTO. And to-do item DTO has attachment DTO, which has properties like ID, name, and size in megabytes. But our attachment in database looks kind of different. It has ID and path, but it doesn't have any size or anything. That's because the files are kept in storage account, but the information that they exist is stored in SQL Server. So what are we doing right there? We have a method like getAttachmentReference for file. We are passing a to-do item DTO. So let's go there. Okay. And for a to-do item, we are for eaching it, getting attachment reference. So let's check it how it looks like by a path. It's calling a blob client and it's retrieving some properties for it, not downloading a file. If it doesn't exist, then it will throw exception, returns a name, and the size in bytes. That's important. Content length. And what we are doing with that information, we are yield returning the ID as a string. We are returning a name, just a file name, without the whole path. And we are transforming a bytes to megabytes. So it's easier to read for a user. And with that, we are returning it in that particular DTO. So there is no need to return whole entities. We can, with a pretty much one SQL query, retrieve all the items and retrieve all the references to a particular blob storage using DTOs. And I think it's pretty common case when you want to return to a user a value not only from a database, but also from the other source of data, like Cosmos DB or let's say storage account, or maybe some other file system or AWS, any place what you want to call, maybe some other external API, and you want to perform those calls asynchronously and get the data as soon as you can, and then combine all together to a one result. And that's why mapping to DTO at the moment of return is a great option. Next thing are the tests, and it will be the last thing in a video related to code itself. So let's start with the unit ones. Maybe to show you the technologies which I'm using right there. I'm using NUnit as a test framework and Substitute as a mocking framework. Fluent assertions to have more readable assertions. I will show you that in a moment. And mock queryable is a library which will allow you to easily mock entity framework DbContext. So in attachment service.tests, I've got tests for attachment service and few of them, maybe get attachment content asynchronously, attachment does not exist, not found. So our method which we are testing look like that. It gets attachments from a database, and if it doesn't exist, if it's not found first for default asynchronous, then it basically should throw not found exception. Let's see if unit tests work correctly. We've got our DbContext substitute created, okay? We are creating our mock, and we are using method from that library which I mentioned a moment ago, mock queryable and substitute. And it's basically creating a DB set of to-do attachments. We can then use and substitute syntax, returns to say that DbContext to the attachments will return that particular mock. And with that, we can perform operations like where, first or default, toList, and a lot of stuff related to querying data and changing it on the particular entity without even creating any connection to any database at all. So we are creating also a service under test. Basically, if those services are not passed, we are creating simple substitute for them. For that, we are passing our DbContext mock and ID of attachment, calling a method and checking whether action is throwing not found exception, because as we have specified here, there are no items in to-do attachments, but we want to retrieve item with a go with new ID. So basically we are calling a database and saying, please give me an item, and database is saying there are no items at all, but specifically there is no item like that in database. So I'm going to say you that, and application is throwing exception with it. The other test has some more complexity. Get attachment contact asynchronously, item was found, and calls file service with correct path. So again, we are creating substitute for DbContext. Now we are also creating for file service. We add an ID of attachment, and we create some expected path. Just a random string. We are using GoIt here. Creating again a DB set of items. Now we are using attachments, same as there. Using as queryable, and then build mock DB set from the library mentioned a moment ago. We are passing that mock to return items from to-do attachments in a DbContext and creating service under test. Now we are calling get attachment contact with the ID of attachment which is present in database, because we are returning that mock which has an item with ID of attachment, same one which we are using right there. So not found exception should not be thrown. And then we are checking whether our file service, so the service which we have mocked, received a call with get content, where first parameter, the path, was expected path. An expected path is a part of the item from a DB database. And the other one is basically cancellation token. So what we are checking in that method is basically whether the item was retrieved from a database and if the property from that entity was used to call a method in other service, if the proper property was used. Those are the two really simple unit tests. And mostly in unit tests, you want to use that library, mock queryable, and maybe mock-u, maybe Encapsulate, depends what you used for mocking. Maybe other libraries, it has some other extensions too. And you basically want to check whether it's retrieved the data or not, whether the exception was thrown, if the correct value was passed or not. So now going into integration testing, we go into services, to-do items service. Now we are checking from the libraries which we are using. Fluent assertions is the same, and substitute is the same, and unit is the same. Only thing different here is auto-fixture. Auto-fixture is basically library which allows you to create, say, objects of a particular class or record or a string or integer with a random value. So you can create a very complex objects which has like 7 child classes, and all of them will have field properties with some random GUIDs, random integers, random strings. So you don't have to worry about arrange part, so setting up the test data, because test fixture, auto fixture will do it for you very easily. So now let's see the test. I'm specifying the behavior of a fixture, which is pretty important with NT framework, that it will not create reference loop, infinite reference loop. So one object which has reference to the other will create it, and then that one will create to first one, and the first one to second one, and then out of memory exception is thrown and nothing is working. So that behaviors are basically saying to only add one layer and don't care about the rest. I'm also setting the options to use in-memory database. And that's extension from Entity Framework. It's a separate library. And basically, it's not an SQL database. We can say that. But it's a database in memory, which can be used with pretty much all the type of queries like where, first to default, find, and stuff like that. But for example, raw SQL calls will not work on it. Also, it's not the same as SQL database, so there can be cases where it differs, but for most of the cases where you just want to retrieve a data and check whether the data was retrieved correctly, whether the where statement was correct, or whether the data was added correctly, then it will do the work for most of the time, and it's a great way for testing. So I'm setting it up right here in our options, and there is a parameter like database name. I'm using a new GUID. Important thing here, if you will use exactly the same name across all your tests, so instead of new GUID, I would specify something like DB name, then that database will be shared across all the tests. So there can be a case where you will modify data and that data will interrupt the other test. So it's a very bad situation, which is hard to find out what happened. So as a good practice, I think it's great to use new GUID inside the test and set it up as new test is coming, and when the test finished, just set it as a null. Now, how the test look like and what it's doing. We are testing our to-do items service, which looks like that, to-do items service, and we are testing method get all asynchronously. What we want to check, whether it returned all the items and whether the items looked correctly. So how it looked like, we have given items available in database. So using out of fixture, we create to-do items. We create also a file service, setting up it. And so basically setting a return with a substitute that whenever the service is called with a path of that attachment, which is passed from a to-do item, then it should return an item with that path and size, which is, I think, 1 megabyte. With that, we are creating service under test, to which we are passing items which are present in database. And if there are any items, we are just adding them to a DbContext and saving changes, because that's in memory database. So it's kind of like existing database. It's not like mocked one. So we have to call save changes when we will add something to it, when we will remove something from it. We also have to call save changes. And returning a service for a service under test method. Now calling get all, creating a list from it with toList async because it returns iAnsync enumerable, and comparing the expected with a result, or the result with an expected thing which we want to have. So for example, size in megabytes 1 when we retrieved the number right here, and also whether it is properly mapped or not. And that's a part of fluent assertion. Also, the other test is checking whether the item was added in database. So we are creating an item to add, again with out of fixture. We create item to add with name and description. We are creating service under test, getting a result from add asynchronously from service under test. We are passing no attachments, no files additional, so only item to add without files in system, so nothing will be added to storage account. And then we create a new instance of DbContext, because when we will take the instance which was used in service, There can be a situation that save changes was not called, but we can retrieve a value from a DbContext, because when we are querying a DbContext, we are going to retrieve items which are added locally and not saved, and we also going to retrieve items which are saved. So if we want to test it whether items are added and saved, we have to create a new instance using the same options, get an item from database using the properties which we specified there, so the name and the description in our item to add, and we are just comparing whether the item retrieved from a database is exactly, ID of it is exactly the same as a result of add asynchronous method. And those are all the tests. So 2 unit tests and 2 integration tests. You can, for integration, for example, use some light SQL server. You can also use test containers, for example. It's an external library which creates a containers in a Docker. But in-memory database is pretty straightforward, easy to access option, which is valid in most of the cases. But you have to remember that not in all of them, and same case for mocking results from database with mock queryable. It will work in most of the cases, but in some you need deeper, let's say, tests which are using correct database. It really depends on the complexity of scenario you have. But we can safely assume for most of the simple applications, which are just creating and reading values from database and maybe updating them and deleting, those 2 approaches which I presented right there are totally fine and will fit your needs fully. So that's everything what I wanted to share with you today. On the last, I want to say what's next. So I'm going to create a part 2 with explanation how to write most efficient queries and what should be remembered when working with Entity Framework, some good practices, maybe mainly to creating queries. Also, in description, you will find some places to learn more about Entity Framework, some tutorials, maybe some websites. Please take a look there. And thank you for watching. Please leave a comment. You have also information about myself in the description. If you want to contact me, LinkedIn is a great place to find, or maybe just YouTube comment. So thanks and cheers.